So this video is for 217 to 222 if you need help on any of the problems. Again, I would like for you to try these problems first. This is here as a reference for ones that maybe you have questions on. So on 217, in an isosceles triangle, so we have an isosceles triangle, the two angles opposite the congruent sides are called base angles. You may have learned in a previous course that the base angles of an isosceles triangle are always congruent. Now we're going to prove it. So in the diagram at the right, triangle SYM is an isosceles triangle and point E is the midpoint. So we have an isosceles triangle and point E is the midpoint of line segment SM. They want us to make a flowchart proof to prove that the base angles are congruent. That is, we're trying to prove that angle S is congruent to angle M. So first thing that I notice is that we know that this side here, YS, is congruent to this side here, YM, by definition of isosceles triangle. I also notice that I have this line here, this line segment, that's in both triangles. So that's going to be congruent to each other. And then they also told us that E is the midpoint of this line segment here, SM. Now, what that means is that this S to E is going to be the same as E to M. So looking at this, it looks like I'm going to have side, side, side. So let me write out some of the statements. So line segment YS is congruent to line segment YM. This is definition of isosceles triangle. I also know that line segment YE is congruent to YE, and the reason for that is this is the reflexive property. Then I was given that E is midpoint of SM. Okay, and that's going to be given. Now, in this situation, they actually did kind of show that in the picture, but they won't. So we need to understand that we need to say that that's a midpoint. Knowing that that's a midpoint is going to lead to the next statement, that line segment SE is going to be congruent to line segment EM. And that is going to be by definition of midpoint. Now I have these three sides, so I can draw an arrow from this statement, and then from this statement, stating that triangle. And let me give myself some space. Okay, so I'm going to do it here, here, and here. That triangle SYE is congruent to triangle. Give myself some more space. SYE MYE MYE. And I need an arrow from that one to there also. Okay, so I have three arrows going there. Let me make my arrows a little nicer. I'll do them in a different color. So that arrow's going here, that arrow's going here, and this is coming from here. Not from the midpoint, but from SE congruent to EM. Now, the reason for this is side, side, side congruency. Now, that's not what I needed to prove. I needed to prove that angle S is congruent to angle M. So knowing that these triangles are congruent, I now can say that angle S is congruent to angle M. And the reason is going to be congruent triangles. So I'm going to abbreviate this. Congruent triangles lead to congruent parts. And that is our proof. Then on the next question, it says, would your proof work for any isosceles triangle? And the answer to that is yes. It would work for any isosceles triangle. This one was not any more special than any other. So looking at 2-18, this problem is not dealing with proofs. This is dealing with area. We have irregular shapes that we're going to find the areas of the pieces, okay? And maybe break these up into different shapes. So for this first one, I am going to be dealing with this rectangle and this trapezoid. Okay, and I'm going to be finding the area of each of these. Now, the area of the rectangle is going to be base times width, base times height, or length times width, which is going to be 2 times 16. Sorry, 2 times 8, which is 16. Jumping ahead here. Okay. Now, for the trapezoid, the formula for area of a trapezoid is equal to base 1 plus base 2 added up times the height and then divided by 2, or 1/2 of the base 1 plus base 2 times height. So I know my base, one of the bases is 4. I need to find this base right here. So let me just kind of draw it in orange. I need to find this base right here. Well, what I know is I have a 1 here and a 1 here, and it's 8 across. So that means that this orange piece is actually going to be 6. Okay. So now what I'm going to do is I am going to have my base 1, which is, let's say, 4, plus my base 2, which is the 6, times the height. Now, the height is always the perpendicular one. Okay, so it's that 3 divided by 2. So that's going to be 10 times 3 divided by 2, or 15. So the area of this one is going to be 15. So then I'm going to take my total area to be 15 plus 16, which is going to give me 31 square feet. Area is always square units. Now on B, I have 3 different shapes that I'm finding here. I have this 6x5 rectangle. So that is going to have an area of 30. I have this triangle here on top, which has a perpendicular height of 3, because they show that this is perpendicular, so that's going to be my height. I also know that if this is 5 here, this is 5 here, so that piece right there is going to be 5. So I have enough to find the area of that triangle. So area of a triangle is 1/2 base times height, or base times height divided by 2. So I'm going to have 3 times 5 divided by 2, which is 15 halves, or 7.5. So this is going to be 7.5. Then I have this triangle over here. And this triangle here has 2 as its height. Okay, so this 2 here is perpendicular. Whoops, that's going to be the height of it. And then it says here that this piece here is 4. So for this one, I'm going to take 4 times my height, 2, divided by 2. So that's going to be 4. So this is going to have an area of 4. So now for the total area, I'm going to add up all of those. I'm going to add up my 30, my 4, and my 7.5. And that is going to give me, let's see, 41.5 square feet as my area. Okay, on problems like this, I should see work, not just answers. Okay, on 2-19, determine whether or not the reasoning in the flowchart proof is correct. If it is incorrect, redo the flow chart. So remember, these arrows are showing the flow, that this implies this. This implies this. If not, we have to redo this. So in this one, we have all dogs love water. Okay. And we have Max is a dog. Okay, so all dogs love water. So that's a fact. And then Max is a dog. So knowing that all dogs love water, knowing that Max is a dog, we can imply that since Max is a dog and all dogs love water, that Max loves water. So I would say that this is correct. Okay, this reasoning is correct. On 220, we're solving. Okay, it's very important that we understand how to solve equations in integrated 2. So on the first one, what I would recommend doing is, I personally like to deal with my x's first. So I'm going to minus 10x from both sides, and I'm going to get 24x minus 80 is equal to -8. I'm going to add 80 to both sides. So I'm going to get 24x is equal to 72. I'm going to divide by both sides by 24. And when I take 72 divided by 24, I end up getting 3 as my answer. On B, I'm going to be minusing 4x from both sides. Again, I personally do my x's first. I'm going to get a -5 is equal to 10. If your variables disappear, you have one of 2 answers. Either nothing's a solution or everything's a solution. This is a false statement. So if you end up with your variables disappearing and you get a false statement, your answer is going to be no solution. Okay, no solution. If I ended up getting a true statement, my answer would be all real numbers, or everything's a solution. On C, I'm going to distribute the 3 here, and I'm going to get a 3x minus 15, plus I'm going to distribute the 2 here, and I'm going to get a 6, let me make that 6 a little better, a 6x plus 2, make sure you're distributing to both things, is equal to 41. Now I'm going to clean up my left side. So I'm going to get a 9x minus 13 is equal to 41, and solve from here. Adding 13, get 9x is equal to 54, and I end up getting x is equal to 6. On this next one, I'm going to distribute this -2 into this parenthesis. So I'm going to get a -2x minus 8. That plus 6 is not affected by that -2. Then I'm going to clean up my left side. So I'm going to get a negative 2x minus 2. I'm combining like terms. Now I'm going to solve. I'm going to add 2 to both sides. I'm going to get negative 2x is equal to negative 1. And be careful, this is not going to be a 2. It's going to be a positive, because it's going to be a negative 1 divided by a negative 2, which is a positive 1/2. That's going to be our answer. Now on 21, we are doing the diamond problems. Now remember, for the diamond problems, we're trying to multiply to get the top, and we're trying to add to get the bottom. So what multiplies to 15 and adds to 8? 3 and 5. Now here, we're going to take the side numbers and we're going to multiply them to get the top. So 3 times 1 is 3. And we're going to add them to get the bottom. So 3 plus 1 is 4. On C, I'm asking myself 5 times what multiplies to 10. So that's going to be a 2. Then what do those add to? 5 and 2 add to 7. The next one's dealing with fractions. So I'm going to multiply my fractions. When I multiply fractions together, let me just jot it down here. 1/2 times 1/3, I multiply top with top, bottom with bottom, and I'm going to get a 1/6. Now, when I'm adding the fractions, I need to get a common denominator. So if I have 1/2 plus 1/3, I need to make common denominator. So I'm going to be trying to get both of them to have a 6 as their denominator. So I'm going to times the top and bottom of the first one by 3 and get 3/6. I'm going to multiply the top and bottom of the next one by 2, and I'm going to get 2/6. So my final answer is going to be 5/6. Okay, 22, this is review. Okay, so we're reviewing angle relationships. So it says use your knowledge of angle pair relationships to write an equation, solve for x, then calculate the measures of the labeled angles. Justify your solutions by naming the theorem. So what I'm going to say is this angle here, this angle here and this angle here are the same because of corresponding angles. So this is corresponding angles are congruent. So the equation I'm going to write is 5x plus 7 equals 9x minus 63 and solve. So I'm going to minus 5x from both sides and get 7 is equal to 4x minus 63. I'm going to add 63 to both sides. So I'm going to get 70 is equal to 4x. I am going to divide by 4. And when I do, I'm going to get a 17.5 when I divide. So then they want us to find each of the angles. So I'm going to go 5 times 17.5 plus 7. And I'm also going to go 9 times 17.5 minus 63. Both of these should be giving me the same value. So when I work this out, I end up with a 94.5. And when I work this out, I end up with a 94.5. So that's what the two angles should be. And they should be equal because that's what corresponding angles are. On B, I know a couple things, okay? I know that these two add to 180. And that's because they form a linear pair. I also know that this angle and this angle add to 180 because of same side interior angles. So I could use either one. So let's say I'm talking about this. So I can write 5x plus 21 plus 20x plus 34 is equal to 180. So I'm going to get 25x plus 55 is equal to 180. I am going to take 55 from both sides, and I get 125. I'm going to divide 125 sorry, I'm going to divide 125 by 25, and I get 5. So X is 5. Then when I put it in, all of these should end up being the same. So 5 times 5 plus 21, 20 times, I shouldn't say being the same. These two should add up to 180. I apologize. 20 times 5 plus 34. So let's see. This is going to give me a 25 plus 21, which is 46. This is going to give me 100 plus 34, which is a 134. When I add 46 and 134, I end up getting a 180. So that checks out. Now, this angle up here should also end up being 46 for a couple of reasons. It's alternate interior angle. Okay, that's one thing. I could have also done that as an equation. So let's just double check the math and make sure that that's what I'm getting. So 12 times 5 minus 14. I get 60 minus 14, and that is 46. So I got that this angle here is 46. I got that this angle here is 46. Those are alternate interior angles. Okay. I got that this one here is 134. Now, the reasoning I use for mine to write my equation, again, there's different equations you could have used. I did a linear pair. Some of us might have done the orange ones and set them equal and done alternate interior angles. Some of us might have done the 12x minus 14 and the 20x plus 34 and did same side interior equal 180. And that's the end of this video.